In this video, we're going to talk a little bit about resistors from a practical standpoint. Resistors come in a wide variety of styles. I'll emphasize resistors which are used to create circuits using wireless breadboards. Furthermore, I'll talk only about the resistors that come with Digilent's analog parts kit. In this video, we'll learn how to recognize the resistors in the analog parts kit and how to determine their resistance values. Here's a large power resistor. Resistors like this one, which are physically large enough, often have the resistance value printed directly on the side. This is a 6.2 ohm resistor. Notice that on this resistor, the maximum power dissipation is also listed, 10 watts. Most of the resistors in our parts kit, however, are these small carbon resistors. The resistance of these resistors can be determined from the colored bands on their side. This resistor, for example, is a 1 mega ohm resistor. It has a resistance of 1 million ohms. Notice that the physical size of the resistor doesn't correlate to the resistance value. The physical size is more closely related to the maximum power that the resistor can dissipate. The 1 mega ohm resistor has a maximum power dissipation of less than half a watt. Now let's look at how to read the color code on the resistors. The resistors in our analog parts kit all have a 4-band color code. This means that the resistance value and its tolerance are coded in 4 colored bands on the resistors. The first 3 bands consist of a resistance value in exponential notation. The 4th band is a tolerance, which tells us the allowable error between the actual and nominal resistance of the resistor. The first 3 bands are read as follows. The first 2 bands represent a 2-digit number that provides the mantissa of the number. The 3rd band provides the exponent or power of 10 by which the mantissa is multiplied. The general formula is shown here. Different colors correspond to the digits 0 through 9. Black is 0, brown is 1, red is 2, and so on. A complete table of colors is provided in the written background material. The 4th band is the tolerance. It's a number which provides the maximum error between the expected and nominal resistance of the resistor as a percentage of the nominal resistance. A gold band, for example, means that the actual resistance value will be within 5% of the value coded on the resistor itself. The bands on this resistor, for example, are red, black, orange. The first 2 bands, red and black, correspond to 2 and 0 respectively, so the mantissa is 20. The 3rd band, orange, corresponds to 3, so the overall resistance is 20 times 10 to the 3rd power, which is 20,000 ohms or 20 kiloohms. So far, all the resistors I've shown have been fixed resistors. That is, their value is a set value which can't be adjusted. The analog parts kit also contains a number of variable resistors, called potentiometers, or POTS for short. These components have a resistance which can be changed by adjusting a screw on the side of the resistor. This is a potentiometer from our analog parts kit. The maximum resistance of the pot is encoded on the top of the pot as 3 numbers. The first 2 numbers create a 2-digit number. This 2-digit number is multiplied by 10 raised to some power. The 3rd number provides the power of 10. Our potentiometer is encoded as 103, so its maximum resistance is 10 times 10 to the 3rd, or 10 kiloohms. The actual resistance of the potentiometer can be adjusted to any value between about 0 and this maximum resistance by turning the set screw on the side of the pot. The potentiometer has 3 terminals with which to connect it to your circuits. The resistance between the 2 outer pins is simply the maximum resistance of the pot. The resistance between these pins doesn't change as you turn the set screw. The resistance between the center pin and either of the 2 outer pins does change as you turn the screw. Since this is a variable resistor, we can't tell what the actual resistance is without measuring it. We'll measure the resistance of our pot with this DMM. Currently, the resistance is about 5.2 kiloohms. Turning the screw one direction increases the resistance. Turning the screw the opposite direction decreases it.